All right, 3.2, solving by substitution. So we already learned how to solve linear systems by graphing. So we know it's the intersection point of two lines. But now we'll learn how to solve linear systems by a method called, and I don't really have space to write it, but substitution. Okay, so I got a step-by-step outline here for you. I recommend that you refer back to this as you're doing this independently, but let's just get right into it. And I'm going to be following these basic steps. So step one, it says solve one of the equations for one of its variables. A lot of times, this will already be the case. Look, I've already solved for x. So step one, done. X equals, I like to write it as 2y minus 6. You could write it as negative 6 plus 2y, it doesn't matter, but just reads a little bit better to me. Okay, step two, now substitute the expression from step one into the other equation and solve. So see how there's an x here? I can replace that x with everything I know x is equal to. So watch what I mean by that. 4, I'm leaving a space here, plus 6y equals 4. So what I'm going to do is I'm going to take all of this and I'm going to plug it in. So I'm going to say, I know that x is really 2y minus 6. So instead of x, I'm going to put 2y minus 6. The reason why I'm doing this is now I have an equation with only y's and no x's. So it's very easy to solve for a single variable now. I'm just going to do some basic algebra. Let's solve. So I'm going to distribute this 4, giving me 8y minus 24 plus 6y equals 4. I'm going to add 24 to the other side. And I'm going to combine these like terms to get 14y equals 28. Then I simply divide both sides by 14. And I'm going to get that y equals 2. Beautiful. I'm halfway done now with this problem. It says next, substitute the value from step 2 into either of the original equations and solve for the last unknown variable. I like to plug it in to the one that I've already solved for x because it'll just give me my answer really easily. So since I already know that y is 2, I'm just going to easily plug this right back into y right there. And I'll be all set. So watch what I do. X equals 2. Y minus 6. But instead of y, I know now that y is actually 2, right? Just plug it right in. And so this is really simple now. All I have to do is just work this out. 2 times 2 is 4, and 4 minus 6 is negative 2. So I got x equals negative 2. All right, the last step is to write your solution as a coordinate point. What do we mean by that? We mean that you're going to write it as x comma y in parentheses. So our answer is going to be negative 2 comma positive 2 in parentheses. There's our answer. We've listed as a coordinate point. Because remember, the solution that we're talking about is when these graphs is a point on the graph where these two lines would intersect. All right, let's go to the next page. All right, so I got a few more examples here. I'm going to do the top two with you, and then I want you to try numbers 4 and 5 on your own. So let's get right into it. Remember, we want to get one of the variables all by itself, and sometimes they've done that for me. So all I have to do is replace the y with negative 7 minus 3x. So let's go ahead and do it. Negative 2x, oops, that's what I want. Negative 2x plus 4 parentheses equals 0. And instead of y, I'm going to put negative 7 minus 3x. See how I'm allowed to do that? Because I know that y equals this, so I can just replace y with what it's equal to. And then just do some basic algebra. So I have negative 2x, distribute that 4, I would have negative 28, positive, nope, not positive, my bad, negative 12x, and this would still equal 0. I'm going to have to add the 28 to the other side, cancel that out, combine these like terms to get negative 14x equals positive 28. Oh, that's very similar to our last problem. Divide both sides by negative 14. And we end up with x equals negative 2. All right, I'm halfway done. Remember what I like to do. Now what I want to do is I want to take this and plug it in for the equation, plug it into x for the equation that's already solved for y. Now, you could plug it into this one. There's nothing wrong with that. It's just going to be a little bit more work. So that's why I like to pick the one that's already solved. So I say y equals negative 7 minus 3, but instead of x, I now know that x is negative 2. So I just work this out. A negative 7, negative 3 times negative 2 is positive 6. So that turns into plus 6. Okay, that's important to remember. So we have to do this multiplication first. That's order of operations. And negative 7 plus 6 makes negative 1. Okay, I got my 2 points. Write it as a coordinate. It's negative 2, negative 1. Boom. Easy peasy. All right, let's take a look at number 3. Look, they're both already solved for x. That's simple. So what I can do is I can literally just like take this whole equation and replace it there. So what would that look like? That would look like, oops, picked the wrong thing again. 2y plus 5 equals 10 minus 3y. Okay, well I could solve this equation. Let's add 3y to both sides. And let's subtract 5. Remember, the reason why I'm doing that is I'm trying to get the y's on one side, the numbers on the other. So what happens here? These will cancel, these will cancel. 2y plus 3y makes 5y, and 10 minus 5 makes 5. Okay, so I just divide both sides by 5, and I got that y has to be 1. Now, it doesn't really matter which one I plug it into, right? They're both going to be pretty equally easy, so I would say let's go up here and plug into this one. You can plug into the top one if you want, but we should get the exact same thing. So I'm going to say x equals 10 minus 3, but instead of y now, I'm going to put 1. What does that give me? Well, 3 times 1 is just 3. 10 minus 3 is 7. Okay, I'm going to list it as a coordinate, and I'm all done. Easy peasy. This is super simple stuff. It's kind of fun, actually. You get to like solve for one, plug it in the other. I kind of like it. Okay, so I want you to try 4 and 5. And I want to point out to you that on number 4, it's already solved for y. But on 5, it is not. But it would be really easy to solve for x because it's just one step and then you solve for x. So go ahead and give both of these a try and then unpause the video when you're ready to check your work. Okay, let's just talk about this real quick. I already had y solved for, so I just replaced the y in this equation with what I know y is equal to, x minus 1. Solve for that, I get 4. Then I took that and plugged it back into this equation where y is already solved. So I get 4 minus 1 equals y, therefore y is 3. There's my answer. Over here, the easiest thing to solve for is the x. I could solve for the y as well, but it's going to take a little bit more steps. So I would just add y to both sides, which is what I did here. I get x equals 3 plus y. I then took that and plugged it into the other x. So 2 times 3 plus y minus y equals 5. Solve for that, I get y equals negative 1. Then I take that negative 1 and plug it in for this equation over here where I already have x by itself. That's my strategy because then it's just quickly, I get the answer. I just have 3 and negative 1 makes 2, and that's how I get my answers. Now, I want to point something out. Let's go to 4 here real quick. Let's say you're not sure or you want to be able to check your work. Here's how you could check your work. If 4, 3 is your answer, I should be able to take this equation and plug in a 4 and a 3. 4 for x minus 1 equals 3. And say, is that true? Well, yes, it's true. And I should be able to do it for the second equation. 2 times 4 minus 3 equals 5. Is that true? Well, 8 minus 3 is indeed 5, so that's true. That's how you could check it. If you plug it back in and you get something true, then you know you did it correctly. If you get something false, then you must have made a mistake and you need to try again. Okay? So you could do that for your work anytime you're lacking some confidence in it, but pretty simple to do. All right, I'll see you guys on the next video.